Hello friends of .NET, I'm Imo Landworth and you can find me on Twitter at TerraJobs. So welcome back. This is an episode that was a long time coming again. So my last one was in December and a lot of people picked me on Twitter. What the heck is going on? You haven't streamed in a while. Is this thing still going? And the answer is yes. A bunch of stuff has happened in my life since then. We sold a home, or we moved out I should say, bought a home, moved in, and besides my full-time job of doing streams, I have two side projects going on, .NET Core and .NET Standard, and they have taken more time than I thought originally. So, in any case, we are back. So, if this is your first episode, this is actually a good one to get started because I picked some small work items for today so that we can actually get back into the mode of working on the compiler. But also, I want to make sure that we can lay the foundation so that we can actually do functions. So that's more or less the big item that we have ahead of us, so that we can actually call functions like printing to the console, reading from the console, getting maybe some random numbers, so that we can actually write some useful programs in our programming language. So let me actually make sure that we are actually still live. I think we are. Let me make sure that the chat is connected. Which seems to be the case. YouTube stream now says sending data, but I'm not sure it's actually live. So let me double check that. There's always some issues with YouTube, it seems. Well, it says live now, so well, in that case, we should be good to go. All right, so yeah, for today, so two things I want to demo really quick. So what we have is we need to add strings because usually when you want to print to the console, you at least want to have some notion of string concatenation, that sort of thing. And then the other thing you want to do is types. So right now we don't really have our own types. We use the CLR types as a lame excuse of not having my own types. That makes it somewhat harder for us to deal with what's known as cascading errors. So when you have binary expressions, for example, you want to, let's resolve the operator between the left expression and the right expression. So the first thing you're doing is you're resolving the types on the left-hand side, then the types on the right-hand side, and then you try to, find the operator given those two types. If you have trouble finding the type for the left-hand side or the right-hand side, then there's really no point in continuing the binary operator, right? And right now we actually don't do that. Right now when our binder fails to bind an expression, we just return a fake expression, which is always of type int. So if the later expression uses some booleans, you tend to get a bunch of cascading errors. And that makes it really hard to root cause what's wrong in your program. So we don't want to do that. All right, so let's just jump right in. So the first thing I want to do is I want to go to our GitHub site here and actually take a look at some of the pull requests I've received. So one of the first ones that actually made me smile quite a bit was the enforce underscore prefix for fields. I use the same convention that we use in our open source, where we don't use this ever, we just use underscore. What's actually his name? Simon, I think, probably not pronounced correctly, but he basically submitted an editor config file, which effectively makes sure that when the compiler or when the IDE generates, fields, it does using our naming convention and doesn't insert this or anything like that. So what did he do here? Well, he just added the editor config file and then set the conventions that we have. So this is awesome. I will totally take that one. GitHub makes you click quite a bit. Especially when you're not having done this in a while. All right, so the next thing I want to do, there was another one where we have some unnecessary return. So yeah, when you do live streaming, what ends up happening is you don't pay attention. So I suppose if I actually expand this guy here, you can see that the way the method is written is there's an if, and then we just fall through. So we really don't need the return here anymore. So that's actually also a good change. I like that. You know, tidies things up, always good. Always good. Yeah, so this is one of those dumb things. I noticed it as well when I was playing with what we do. So we have this thing in our REPL where we do the arrow keys to basically show the previous command so that you don't have to retype it if you made a mistake. And so this history thing apparently crashes badly when there's no history in it. So this fixes that. I think I've tested that as well, so I'll just take that one as well. So this is programming, right? You just merge changes in and then you are in a better shape. Yeah, this is, I think, a very similar one. This is actually super neat. So when we did our REPL, so one thing I did is I basically implemented my own read line, if you will, where we intercept keys and then modify the text line that allows us to do interesting things like, you know, history and syntax highlighting, all sort of thing. But some editor commands are not supported. So for example, when you're at the end of the line, you hit delete, what you would expect from a text editor that we take the previous line and merge it the next line and merge it with the previous line, which we don't do. And this is what this adds that. So basically, if it's the first line, then don't do anything. Otherwise, merge the line. I assume this works, right? So why would it not work? We'll find out soon. All right, so then, yeah, this is another one of those things. So the way our REPL works right now, so in general, a REPL is a read, eval, print loop, right? Where you effectively write some snippet of code, you hit enter, and then, you know, the compiler effectively evaluates what you have typed. What you generally want is you want to say, well, if I write something like a plus enter, you don't want the compiler to give you an error message for, well, you're missing the second operand, right? Instead, you want the thing to just continue and then accept input until your expression or statement is complete and then evaluate that. The way I've implemented this right now is pretty lazy. I'm basically just saying if the line has any sort of parsing errors, I just keep consuming more lines, which has the downside that if you made any syntax error on the previous line that is unrelated to the fact that you're not done, then you just never complete. You just basically go into an infinite edit cycle. And so what he did is actually quite smart. So what he did, he said, well, if we have a syntax tree and it has, and the very last token in the syntax tree is inserted by the parser, that means you're missing content. And that's when we keep going. Otherwise, we just report an error immediately. That might not be the right way of doing that either. But that's much, much closer to where you want to be than what we're doing right now. So I'm inclined to take this. I probably tweak this a little bit. Like for example, I probably move this function probably where it logically belongs and not keeping it in the REPL. But you know, as a starting point, I think this is a really neat addition. So by all means, keep the PRs coming. I really like that. It's a very easy way to engage with you folks. So one person's asking, are we using an existing compiler or are we creating our own compiler from scratch? So this live stream is literally writing a compiler from scratch. So the APIs and the patterns and the style that we're using is very similar to Roslyn. So you can kind of think of a microscopic version of Roslyn where I obviously simplify things quite a bit to actually be able to write it. But the idea is the compiler is completely written from scratch live on stream. So everything that's checked in the repo right now, I've written live on air with people watching. So it is something that you can totally do by yourself. All right, so now let me actually go to my command line window if I still have it open anywhere. Oh yeah, feeling really bad at butchering and looking at things today. All right, let me pull what I just got from the server, and then we start our episode by saying episode 10. All right, now we are good to go. So as I said, one thing I want to do here is, let's actually make sure that it builds. seems to be the case. Maybe tests are also passing. That would be kind of neat. They are. All right, so then let's do what I just said. Let's move some things around. So what is it? GetLastToken. Yeah, so GetLastToken, I think I want to actually have on syntax node itself. So let's go to syntax node. So we already have some basic navigation APIs like getChildren, for example. We have a lot of pretty printing stuff here. And then I think what ends up happening eventually is that we will have more of these, navigational commands. Like for example, getChildren is just the direct children. In XDocument, the XML DOM APIs, we also have descendants, which is basically your direct and indirect children. Roslyn has, I think, a bunch of those. You can, move up your ancestor, your parents. You can move down. You can just enumerate the tokens. So this logically all belongs into this space here. So for now, the only thing we need is this one here. So make this a public method. Probably should be an instance method. And then we say if we are actually a syntax token, then return ourselves. Otherwise, we basically say, get children last. Yeah, so this always needs to work. So basically, if we are a token, that means we don't have children anymore, so we return ourselves. If we are a node, that means we must have children. Otherwise, we have made a mistake in the construction of the parser. That makes no sense, right? Because at the end of the day, when you construct a parse tree, you're doing it from tokens. So that thing has to have at least some, token as a child. And so then you basically just say, give me the last one, and then you call GetLastToken on that one. And so this way, it should always work. Let's go to the REPL and actually fix our error. And we say, so what is root? Shouldn't that already work? Smart point, we need to exclude end of file token. Yes, good point. What's the problem with it is missing? Really? I thought he added that. Did he not? That is funky. Did we accidentally delete something? No. Maybe I'm slow this morning, but syntax token. Public bool is missing. What is it that you're complaining about? What do you think is on this type? Clearly you're wrong. Clearly you are wrong. All right, let's just close Visual Studio Code for a moment. I know it's early and all, but it's always helpful when your IDE does not lie to you. Let's just run it and see what happens. All right, so if we say, let's say, what would be good? This is clearly a parse error, right? But it's also missing stuff, so maybe that's a bad example. Let's say, right? So this is an example of something where we're not missing anything at the end, but we do have a parse error here because we don't support floating points right now. So we're super confused about the period, but we don't consume more lines. So basically that's an example of something that this thing is actually fixing. Super neat. So let's start with adding this guy. And then we just say move GetLastToken to syntax node. All right. Yeah, the other thing I wanted to fix, now that I'm seeing that, syntax node. So technically, sorry, syntax token. Technically, I'm not sure I want to do this. Because logically what you want, I guess we already do this here anyway, we say when text is null, then length is 0. So normally what you would do is you would just say if the length is 0, but that's the same thing anyway. So never mind. Never mind. Yeah, the only other thing in the REPL I wanted to do before we go on to do something useful is fix the colors, because for some reason when I did the version live on stream, I only handle keywords and numbers. And what I also want to handle are identifiers. So var is identifier. Identifier token. And I want those to be dark yellow, I think, right? That was what I said. Else if, I guess I want it here. Else if is identifier. Then we do dark yellow. And then the other one I wanted to do was numbers should be cyan. So let's do this. If it's number, then let's do cyan. And then we just say else it's dark gray. So if we run this, things should look a little bit nicer. So let's say let x equals 10. Nice. And now it looks a little bit more colorful. Not that it makes a huge difference, but I like pretty things. And so let's just do that so we actually have something nice to look at. Prettify the output. Lucas is right. I forgot to delete the old version of GetLastToken. All right, GetLastToken. Not the other one. Yeah, so we should get rid of this guy here. Good catch. Good catch. Let's get rid of this guy and say remove old version of GetLastToken. And while I'm at it, let's just pretend this never happened, because it makes it a little bit easier to follow after the fact. And that's great. My other Sublime window with my notes is now also zooming in. That's not what I wanted, but hey. All right, so now I think I'm in a good state to do strings. So one thing we want to do is we want to be able to do things like this, right? When we say let hello equals test, right? Do I want single quotes, double quotes? I think I want double quotes. We want that to work. So basically the first thing we want to do is we want to change our Alexa to actually recognize string tokens. And so there are multiple ways how we can do this. Right now, this is where we do the variable length tokens, read number, read white space, so this kind of Seems like this should go in here. So we say if you find an open quote, then we say read string. And then we return. No, then we break. And yes, that doesn't work because we are in the context of chars, not strings here, so that should work. I think I can even do that. That makes it actually more readable. All right, let's generate this method for us, and it probably should go right here actually. So let's think about in a second how we would do this. So first of all, we skip the current quote. What? Anyway, so then we basically say while the current, no, actually while true, I think. Yeah, we probably want to do this. Switch current, we would say case quote, then we might be done. And then at the end we would say, yeah, what does text work right now? Text we actually do handle here. So the only thing we need to set here, I think, is the token kind. So we just say kind would be syntax kind string token, which we are about to add. So let's find a position where this belongs. Seems like somewhere here seems reasonable. What's your problem? Kind is assigned. Yeah, that's fine. I'm actually code detected. Yeah, so one thing we want to think about is how do we want to do escaping? So normally in almost all programming languages, you can have escape sequences where you can say, test, and I want to have a quote inside, and then, more text, right? So that's one way of doing it. The other way you can escape a quote would be to just use double quotes. So that's another way of doing it. Personally, I don't have strong opinions here. I would probably just go with double quotes because why not? Let's do that. So then we say, in order to keep track of what the actual value of our string is, we create a new string builder here that we use for constructing the value. Because the value of the string is obviously not this, right? It would be, the single quoted version, right? And no leading and no trailing quotes. And then we would say our value is sb to string. All right, so first of all, we need to handle our special cases. So so the first question is, do we support things like this, where you basically do this, right? And so you basically have a line break here, and then the string continues here. Some programming languages do that, some don't. So it kind of depends on what we want to do here. I think for simplicity, we will go with single line only. For now, if we need multi-line, we can add that later. So basically, we would say if you find end of file, or if you find a line break, any line break really, that would be an error. And then default would be advance the position, and sb append current. So in this case, yeah, we need something like a marker that we know when we are done. So we say var done is false. We say while not done, let's say. In this case, we are definitely done. Done equals true. And we probably want to say diagnostic bag report. In our case, unterminated string. And I think we want to have a position here. So do we record the start of the token? I think we do, right? So start is the start of the current token. Yes. Okay. So let's just report this thing at the start position of the at basically the open quote, right? So start length 1. That seems like the best location. So let's generate this guy. Lexa arrows go pretty high up, so invalid number, bad character. Yeah, this is clearly the first parser error message. All right, let's make this public. And then we say something like this. Unterminated string literal. Yeah, we don't need a format string here, we can just do that. And that seems reasonable. Yeah, so somebody's asking about other control characters like \n, \t. Yeah, we probably want to handle those as well. But for now, I just want to get some basic stuff going. And of course, needs to support emojis. Yeah, you kind of get that for free. So the reason you get this for free is because if you think about how we do parsing here, right? Basically, we just search for the next quote. And so, yes, we're not technically advancing, character by character through the string, because strings can be, or characters could be multiple bytes, not just 2, right? Because if emojis might be 6 or 7 bytes, right? And yeah, basically, we would just look for specific values here which don't conflict with the emoji. So if you have emojis in the string, it would just work. You can check that later, actually. Yeah, like my logic is not done yet. I'm just writing the overall thingy here. So okay, so this is the error case when we screwed up. We don't want to increment position here because these guys are effectively, we read too far, so they are not logically part of the string. All right, so if we find a quote, then the question is, if the next one is also a quote, then we just eat one of them. If it's not, then we don't add it because it's a terminating quote, but we do increment the position. Sorry, we advance by 2. We eat that, and we are done. Right? Something like that. All right, now let's first fix our internal consistency thing here. So we have this thing called syntax facts, where for every given token, we return some information. So we have, I think there's nothing here because it's a dynamic code and we don't return text, obviously. Okay, that's fine. That should work, actually. Let's see what happens. Okay, that's bad. Yeah, actually, let me fix that because that is annoying. So one thing we could do in our REPL to force it to report errors is to say if the last 2 lines were both blank, then how about we consider this also complete? What's the easiest way to do that? We could say var last two lines are blank. Now this is, don't write this in production code. I will fight you if you do that. But we could do text.split environment new line reverse say where string is null or empty s. I guess take while we say take to count to, right? I mean, that's super hacky, but probably gets the job done. And we can say if last two lines are blank, return true. Hopefully that allows us to see what the actual parse errors are. Let hello equals hello. Aha. Well, in that case, that's actually not bad. I don't know why I get the error twice. But that is actually easy to handle. All we do in our parser now, we basically say, wherever we are saying parse literal, parse boolean literal, we would add parse string literal, string token, we probably have to handle this guy here. No, we don't. Oh, yeah, that's good. And so then the question is, where do we handle this guy? We say, yep, here's where the literals are happening. All we have to do is add our string literal here. And then we say parse string literal. Let's try this again. Is the background real or is it green screen? No, that is actually my real background. This is my, it's not really, it's not my backyard, but it's a lot of green stuff, so feels like my backyard. Shouldn't append be called before position ++ in default? Probably. We'll find out now. What happens when I do test? Yep, he just everything is shifted by 1, which is not what we wanted. Still begs the question why the trailing one is in though. Well, all right, this is, I think, what we want. Let's check for tests. So if we now actually run tests, the test should fail because I have one test that ensures that I have all token kinds covered. And we don't cover string literals right now. Yes. So Lexer test covers all tokens. We don't have any tests for string tokens. So that is good. Our infrastructure finds out when we made a mistake. Always good. So here is how we do that. So here's our dynamic token. So add a few test cases here. So we would have, of course, this one has to include the quotes in the string, right? So this would be a simple case. And then we would have one where we have a double quote on the inside. Yeah, this is super hard to read, but so I expect this to fail as well. So we have also a test that combines all tokens. We will not be able to parse subsequent string tokens because we do. So if you have one string token directly after another string token, we just parse it as one string with a double quote in the middle, right? So when we say token pairs, we have to say if both tokens are string tokens, then we can't actually, like we actually need a separator in between. That should handle that. So that seems fine. Someone is saying we already do position plus plus for the current quote. Which case are you referring to? Because I believe it's correct now, based on what I have seen. Well, let's actually see what ends up happening when we let hello is yeah, so we expect one quote and then nothing around that. Right, that seems reasonable. Someone is saying, what do I think of DI? I think DI is a very useful concept for applications. I think it's overused by people. It's not the, cure world hunger kind of thing. However, like if you design an application, like larger applications that are, stateful effectively, if you think about, how Visual Studio works, you have tool windows, you have document windows, and so you have some sort of state, and you need to wire things up in such a way that state is generally encapsulated, but you expose state to other things. And with DI is actually quite neat because you can basically have services and you can import services, and those services can expose the data. And so that means if you write a tool window, in the tool window you can basically request other people's data without effectively having a ton of globally statics where you cannot really model instances or multiple things like document windows where you may have more than one, right? So DI is quite useful for that. And it's honestly, if you make things like ASP.NET where pretty much everything across the stack needs to be pluggable, but you don't want to force everybody to pass things around all the time, then DI is kind of the only way you can make that fly. At the same time though, for libraries, I think DI is horrible. You should not write libraries and force DI to your consumers because first of all, there's more than one DI system usually, so you want to play nice with whatever DI system the application wants to use. And I think for things like a compiler, DI doesn't really make a lot of sense in my opinion because compilers are very phased usually, meaning you do things in specific orders, right? First you parse, then you bind, and then after you did binding, you do code gen or lowering in between. And so you're better off just coding it in that way. And especially when you think about other things like parallelization, or I want to parse in parallel, I want to bind in parallel, I want to combine the results, then with DI it's just artificial. And then you just, you basically have flexibility in the compiler with DI that you don't actually need. So I think for us it will be overkill. Now for the IDE side though, I think DI will be super useful because in the IDE side you do have, features that interact with each other and you want to get access to various things. And I think for the IDE layer it would make a lot more sense to use DI. All right, so one thing we should do, we should add a test for the unterminated string case. So what happens today when I do that actually? Test unterminated string literal. And then we get an error at the opening quote. I like it. All right, so then let's test that is actually the case. So Lexer tests. Actually, that method is not really our naming convention for normal tests. Any tests down here? These are the stubber methods. Okay. Okay, let's do a fact, and let's say public void Lexer Lexus unterminated string. So how hard can it be? How do we want to do that? Maybe I'm blind, but I don't really see where I'm doing that. Who's doing the actual parsing here? Oh, it's one of the methods that collapsed. Okay, we use parse tokens. So we would say tokens is, what is it? Syntax tree parse tokens. Okay. So in our case, we would say text, and then we would say bum bum bum. Yeah, how do I get diagnostics on this guy? I don't think I get diagnostics today, right? I do not. So I think what I want to do is I want to have, I think, an overload of this guy that gives me the diagnostics. That might be a bit ugly. But yeah, there's that. All right, this is an example where local functions are useful. So we say lex tokens, and then we say we need the lexer. Yeah, you can't have out methods, or you cannot have out parameters in a method that uses yield. So I need to break this apart. So I just do this and I say, so the result is is lex tokens. And then we say diagnostics equals L dot diagnostics to immutable array. And then we can say return result. And then we would say this guy is basically just return parse tokens for text out discard, because we don't care. Okay. And then we probably want one overload here that does the same thing here, so we actually can parse in. This is the thing that I don't like when you have different shapes and you end up with a bunch of overloads. But hey, it is what it is right now. So we would have to call this one and we would say out diagnostics. All right. And then we can say out var diagnostics. So the token kind I expect is string token, syntax kind string token. And of course I would say the text I would expect would be, let's do this, introduce constant, no, introduce local. And honestly, that's one thing I don't actually like. Who cares? It's so much nicer to read. Okay, then diagnostic is assert single diagnostics. And then I think we expect something like, what do we want to assert here? Well, for starters, probably the message and the span. Yeah, let's do that. Oops. And then the span would be, what is it? New text span. In our case, we said the first two, that would be zero length of 1. Yep. And then the message would be something like unterminated string literal, right? Yeah, what are the chances that this will just work? Somebody's asking how do I like the C# extension in VS Code over VS? I actually like it quite a bit. Yeah, test execution is a bit of a pain though, because I do it on the command line all the time, which is not that great. Like, for example, I have no idea how I would debug my tests right now. I have not figured out how to do this in VS Code. Okay, where do you fail? You fail in line 22. That would be here. So you expect a diagnostic, but we don't actually get a diagnostic. Okay, so the string is parsed correctly. What? Out diagnostics. Right, relax everything. Then we ask for the diagnostics. Ah, good call, good catch, good catch. You are absolutely right. Somebody says, yeah, the iterator is lazy, so this one doesn't actually, yeah, that's it. That's one of those pitfalls, right? So what ended up happening here is, I call LastTokens, but because this is an iterator, meaning it uses yield, calling this method does nothing, right? All it does, it basically just instantiates the state machinery that would actually iterate over this. So unless somebody actually pulls on this enumerable, you effectively have no diagnostics yet because you haven't actually read anything. So what we will do is we will just force this thing and just say, how about, and now here we can say to immutable array, which will force the evaluation, and then things are good, maybe. Thanks, Lucas. This was a good catch. You guys are paying attention. I like that. It's a. All right, what did it say? Assert failure, string literal. Oh, we have a period in there. That is too bad. That is too bad. All right. Neat. All right. So let's do this. Let's add this one first. And let's say allow REPL to force evaluation. Sometimes our heuristic for detecting whether the submission is complete doesn't work, in which case we want the user to have the ability to force the completion. We do this by adding to blank lines. So let me actually enable spell checking here in this guy. Which I think hopefully, yeah, it's actually working. Yeah, this line break is unfortunate. Good enough. Second one is, let's fix this one, yeah. Rename test to match convention. And then we would say, yeah, let's actually go to the what? Diagnostic bank, lexer, parser, syntax kind, syntax tree. Oh yeah, here's what I thought. Okay, so let's add this guy here. All right, so this is basically just the ability to parse tokens and get diagnostics. Add ability to to get lexer diagnostics. When parsing tokens only, we currently have no way to get access to the lexer's diagnostic. This adds an optional out parameter. The real fix, of course, would be to mirror what Roslyn is doing, which is exposing the diagnostics on the actual tokens, which makes the output neatly self-contained. Unfortunately, doing that is not super straightforward unless you accept horrible implementations of every token having a diagnostic collection. So let's not do that yet. All right, so this is actually our just the changes to get string literals supported. Add support for string literals. Yeah, it might actually be nice to just open the PR already. So that if people want to get access to the code, they can. All right, so this is all I had for string literals, I believe. Let me check my notes. Yep. Somebody's asking how do I enable GitHub dark mode. Well, it's very simple. You just ping Nat Friedman on Twitter and he gives you a special version of GitHub. No, the way I've done it is there's this extension you can install. It's called Stylish for Chrome, or in my case, I'm running the new version of Edge, which is based off of Chromium. And then you can install the Stylish extension. And this one has effectively styles for any website. And so there's one for GitHub. And I think the one I have installed is called GitHub Dark Theme by Snazzy. I actually quite like it. There's also, I think, I don't know, do I have a style for this? Or I have an extension, I think, installed that actually makes GitHub wide, because, you know, we have wide monitors and it seems wasteful to squeeze everything in the center. That's also why my screen real estate is a bit more used than maybe on your end. All right, so then let's do the following. Let's actually talk about symbols right now. So what we have, so the general phases of our compiler is in the syntax tree, we start lexing, right? And then we have tokens, and the parser basically constructs syntax nodes. And then the first thing we do with them is we throw them into the binder, which basically creates what we call the bound representation, where, you know, types are being determined, you know, variables are being resolved and declared and all of that goodness, right? And so one of the things that the binder does is, you know, it declares variables, so they have to be represented somehow. And right now we only have one kind of symbol, which is the variable symbol. Eventually we'll also add a function symbol, of course, and a parameter symbol and all of that. And so it seems like we should move this guy somewhere else. So one thing I also want to do is there's this thing called label symbol, which is internal, which is only used by the binder to represent effectively, you know, all sorts of loops. There's this thing called lowering, which basically takes our high-level constructs like for loops and while loops and rewrites them into effectively gotos. And for those, we need labels. For some reason, I went with the term symbol here, which is actually not great, because this is not the kind of symbol I want to expose publicly, right? This is just an internal helper in the backend of the compiler. So what I will do is I will move this guy into binding. Yes. And I will, of course, was it binding? Yes, okay, binding. And then I will rename this guy to bound label, because that's kind of the nomenclature we went with. And then I think I want to rename the file as well. So this makes our bound label no longer a symbol, which is probably the right thing. So let's see whether it builds. Yeah, somebody's asking, wasn't stylish removed from all extension stores for tracking everything users were doing? Maybe. I'm actually not sure. I think at some point it disappeared, but it reappeared. Sounds like I should be careful with that extension. All right, so this is the rename of the label symbol. Let's call this rename label symbol to bound label. All right. Well, the only thing that we have that is called symbol is actually what we want to expose publicly. So first thing I will do is I will create a new folder here, so for all our symbols, because we will have more moving forward. And we move this guy in there. And of course, we move this now into the symbols namespace for consistency, which now means, of course, nothing compiles. All right, so I wish there would be a simple fix for me to not having to go to all these guys, but I don't know what that would be, so screw it. Bound scope, same thing there. Bound variable declaration, same thing there. compilation, same thing there. Evaluator. Where are you? Variable symbol. Okay, lower probably is also one that needs it. All right. And of course our tests. Sweet. Yeah, Troyana is asking whether Minsk is an interpreter or does it generate IL. It currently is only an interpreter, but I have, when I played with the compiler, I actually wrote a backend as well. And so one of the goals of the stream is we actually will use mono-Cecil to actually emit real bytecode. So we have an actual compiler that takes files and then produces .NET bytecode directly. Move variable symbol to its own name, to a separate namespace. All right, so this now enables us to actually add a few more symbols here. Okay, so Jason is asking whether why I would use mono-Cecil over reflection emit or reflection metadata. So the reason for that is mostly simplicity. So reflection emit is just the wrong thing to do. And the reason for reflection emit, originally, 20 years ago when we did .NET Framework, there was this idea that reflection emit would be used by compilers. However, that's not what turned out to be workable. And that's for two reasons. One of them is ref emit fundamentally is using reflection, right? So you have the reflection object model, and then you add effectively APIs to generate IL, right? However, you are still only able to emit code with ref emit that targets the runtime you are currently running on yourself. That now means that the runtime the compiler is running on and the runtime that the user needs to run on must be the same runtime. And it's generally bad because there's really no reason. That the fact that the compiler is implemented in managed code should be an implementation detail. You should be able to have the compiler run on, let's say, .NET Framework and emit code for .NET Core, right? That seems like a reasonable thing to do. So that's why most compilers, or no compilers that I know of that are production ready, are using ref emit for CodeGen. Now, some compilers have an interactive experience like our REPL, so F# interactive, C# interactive, and some of them actually do use ref emit for evaluation purposes, right? Because in that point, you're running code live, and at that point, the compiler, if you will, is part of the user code because it's all running in the same process, right? In which case, ref emit is fine. So ref emit is just the wrong API, at least for us. Reflection metadata is a very low-level code generator. Basically, all it does, it has support for creating bytecode assemblies on disk, but it doesn't really give you any sort of like representation for types or methods or anything like that. It's very low-level. So Roslyn is using reflection metadata because they have their own object model already, and so they just lower it directly. But I found Cecil to be easier to use. But I can give it a shot. I mean, I don't know. I have not tried it in a long time. So maybe that's a better way of doing it. I can't even remember the Minsk syntax. Well, you're not alone. Neither can I. It took me a while the other day to be able to write variable declarations again. That is what happens when you have your own language. All right, so now let's talk about what we just want to do, which is really we want to add the notion of types. So right now, actually, let's check out how this works right now. When we have a bound binary expression, or a bound expression in general, of course, expressions have types, and the type that we are using here is system.type. So we're using the CLR type system for our language, which is honestly not the right way of doing it, because we usually want to have our own concepts on top of that. Since we are admitting to .NET metadata eventually, it may not be a big deal, but for practical purposes, it's always better to have your own type symbols. All right, so let's do this. So we have our own type symbol, right? And then we would say, now this thing needs to be smarter. Why do I have to fix the constructor every single time? So basically all symbols have names, so maybe we should actually have a, can I do this? No, I cannot. Can I do this? No. Okay, I actually have to type it out. Okay, we need an abstract class symbol. This one will have a name. It will have a protected, no, in our case actually it will be private protected, because we don't want anybody else to implement symbols. String name. Yeah, symbol, and then we just say, do that. And then we say this guy is actually extending symbol. So that would be base name. And then we would say same thing here. This one extends symbol. So we just say base symbol. No, sorry, name. And then of course, this should be internal. And then of course, this guy should no longer exist. Okay, so let's just start with getting that to compile. That should be enough. Okay, that compiles. We expected that, of course, but okay, one thing we should probably add, since we now have a bunch of different symbols, we probably want a symbol kind, so we can actually switch over them, in which in our case we only have variable right now. And then we say we have a public symbol kind, which is a getter and would be abstract, right? And then this guy would just say symbol kind variable. Yeah, it should also just build, but let's be sure on that. Let's do that. All right. So let's just do this one, and we say add abstract symbol type. All right, so now I think it's time for us to introduce the type symbol. Actually, there's one more thing we should probably be doing to make our own life. Override toString. And that is, probably that should just return name. Well, How about this? That's what these guys are for. Yeah. And of course, we need a return type. So now begs the question, what does this guy do? Okay, nothing useful anymore. Let me pull this guy into the other one that we just had. I know, I'm a bad person because now I'm force pushing, but that will teach you. Pulling my latest changes all the time. Anyway, so that is our variable symbol. Now the type symbol. So now we have this guy, and of course we need to add the inner member now. And now it's fun, now, because now we go into yeah, so first of all, how many types do we actually have? So we don't have that many types. So let's just create fixed types for our language right now. So we have an int type, right? I actually call it int. We have bool, and we have string. Right? These are the primitive types that we have. So that would be bool, that would be string, right? Of course, that will be bool, that will be string. Helps if you type it correctly. All right, then in that case, we can actually make this guy private because we only have one of those guys. Now let's see. So when we go to bound expression, instead of returning type, we will return type symbol. And now we will have fun recompiling the world. Of course, this guy needs to return type symbol. The bound binary operator has to, instead of using type, it has to use type symbol. Type symbol, type symbol, type symbol. Of course, this is type. All right, all of those guys will be type symbol dot int. All of the bool ones will be type symbol dot bool. Right, and then this guy will be type symbol. All right, so this is bound binary operator. Yeah, this guy needs this guy. Assignment expression. This guy needs to override type symbol. Virtual expression. Yeah, this is a bit more tricky. So now we would say, instead of having this guy computed on the fly, we just say it's computed once in the constructor. And so we would just say, you know, if value is int, now let's say bool, then we say type is type symbol dot bool. Else if value is int, then we will do int. Else if value is string, then we say string. And then else we say bad things are happening. We say throw new exception, unexpected literal of type value Okay, so that is the literal. Okay, bound unary expression, that would be type symbol here as well. Of course, now we have to do bound unary operator, so everything that is a type here. Okay, that's bad. Okay, type symbol. And of course, this would be type symbol. Okay. Of course, this guy now needs a type symbol as well. Now the binder should be the only area where things need to happen. Okay, instead of saying type of int, you would say type symbol int. Okay, so this is, okay, let's search for type. So this is type symbol. Type symbol. Type symbol. Type symbol. Type symbol. All right, so type symbol. Okay. I think the lexer probably we just broke that because we said, yeah, we need type symbol int. Okay, so that seems reasonable. And now here's probably a few things where we need to fix things. Yep. That would be type symbol int. Neat. Does build. It does not. Evaluator. Okay. Yes. Isn't there null reference exception in bound literal expression possible if value is null? That is true in the error case. Yes, we will dereference that. However, we don't have nulls in our language yet, so that's why I don't think we care. But yeah, once we handle null, we probably want to do that. System boolean to system in 32. Okay, so that's one thing where we basically now we changed our symbol representation. So now instead of using system.boolean, we actually use the nice names that we have in our language, and that's kind of what we want. So these are examples where the tests are actually wrong now, not the product code. So this would be evaluation tests, I guess. So we would say system int32 should be int, and system boolean should be bool. Bugfound is asking, is there something like C++ typedef type in C#? No, C# doesn't have typedefs. The closest you have is using aliases. However, using aliases are not great because they're only per file. So I can totally say using type equals system.type. Oh, sorry, could be, what did we say? Minsk, code analysis, symbols, type symbol, right? I can totally do that. However, I have to paste this into every single file. So that is not what you want usually. So they don't have the notion of typedefs that are global. And yes, there are cases where I wanted that too. All right, so let me quickly check my nodes. We do have variable symbol. Yep. Expose to statics, replace usages of this one. Yep. All right, so that one seems to be mostly what I wanted for that part. So here's all the tests that we fixed. Yeah, here's the null reference exception when value is null. We probably shouldn't accept null to begin with right now. But hey, we don't do argument checking for internals. Replace system.type with type symbol. All right, so now to the point where we said earlier we have this problem right now where we have cascading errors. So let's look at what I mean by that. So here's an example of an expression that causes cascading errors. So when I say 10 times some Boolean value, right, then we cannot really bind this expression to anything useful because there's no operator, star defined for bool and int. So this whole expression here will evaluate to effectively an error. But if you look at the code, if you go to bind binary expression, basically, if we can't, so we say basically bind for the left type and the right type. If we can't find an operator, we return an error, and we return bound left. Because you have to return something, right? But bound left is whatever bound left ends up being. In our case, bound left is just an int. And so now, basically that means you get one error for here, and you get another error for the whole expression because you're basically no longer doing anything useful, right? So basically you get one error here, and you get another error here because now you have there's no operator or defined between int and bool. What you really want is you only want to get this error here. And then this guy should basically say, well, the left expression is of type error, so there's no point in me trying to bind the or operator. This way you have what's called cascading errors, right? You no longer cascade the error forward and drown the user in error messages. You only report the root cause. And then when the root cause is fixed, well then, many other issues are no longer happening anyway. So what we really want to return here is instead of returning left, you want to return an error expression. But expressions need to have some sort of type. So what we will do is you will add this thing here. So where's our symbols? Our our type symbol, we introduce a new type called error, type question mark, which is basically return for things we can't bind. And then on top of that, we will create a new expression bound error expression. We say the type symbol is always type symbol error, and the node kind is bound node kind error expression, which doesn't exist yet, obviously, so we have to create this guy. So now we can say in those cases where we say return left, we just say return new bound error expression. The other option that we have, instead of returning error expressions, we could also just create a bound binary expression with like a null operator, for example, right? The problem with doing that though is now you make your life harder in the later phases, because now you have to deal with more corner cases where parts of your tree might return nulls all of a sudden, and that might make it actually harder, right? So that's why I generally prefer having a more, simple understanding that if you find a bound binary expression, it actually is a bound binary expression and not some, error state. In which case, if you check for one, you always get a valid one back. So let's just run this one and then see what ends up happening. So let's take our example from earlier. So we still get two errors, obviously, right? Because we just return error now. But now instead of saying not defined for int and bool, now it says for error and bool, right? Because now it actually propagated that this thing here actually evaluates to error symbol. And so now it says, well, I cannot define the type operator for error and bool. And so what you would do now is you would say, well, if bound left, type equals type symbol error, or bound right type equals type symbol error, there is no point, right? So you bail effectively. Which now means if we run this guy now, we get a single error, and as soon as we fix this one error, right, the program just starts working again. So we don't report, a ton of cascading errors. So now let's actually go through the binder here and see where these things happen. So here's one. So we say if bound operand is error, then bail. And of course, if we can't define the operator, same thing, we say bound error expression. Bind assignment expression. So this is a good one here where returning an error is actually not useful. So when you say an assignment, so assignments are right associative, right? You can say A equals B equals C in our language. And so now let's say we are at this location here and say, well, we cannot actually assign b because b is not defined. Instead of returning an error expression here, it makes more sense to actually just propagate the right-hand side. Because if a exists, then things will just work out, right? Same with the variable is read only. We don't actually care. We just report this error and just keep going as if it would have been okay, because it reduces the number of cascading errors. And then same thing here when we say bound expression type is not type, report cannot convert. Bound expression. Basically, if C is not the right type for B, then we just return C. That might or might not be good, but the question is what's more likely here, right? Like, is the right expression the assumed correct one on the left-hand side? So this is all about tweaking effectively how many cascading errors you get, right? This is not well defined necessarily. It's just all about what developer experience is better, right? Like the program will not compile, so you'll report it diagnostic, so you don't emit code. So you just pick effectively behavior that is returning the least amount of problems for your customers. So bind name expression, we say if we cannot resolve the name, then we return a hard-coded bound literal right now, which is not what we want. So we would probably say bound error expression, because we don't actually know what the name it is. And then say same thing here, if we can't look up the name, then we also return error expression. That makes sense. Literals are always well defined. Yeah, that's why right now we cannot actually create null references here, because we only ever pass in a value. And what expression can this be null realistically? I don't quite understand. Because if it is null, we probably should return an error expression. But yeah, let's leave that for now. Bind expression. Yeah, this should basically address the cascading error case. All right, there was one issue here on GitHub, I think, I wanted to take a look at. So Peter reported that we have this behavior where our parser will insert tokens, and when it does that, it has a null text, and that can itself cascade in errors in the binder, because the binder will now try potentially to use that null text and do something that would, like, for example, declaring a variable or referencing a variable, and then it crashes. The general philosophy of the binder is that the binder always needs to work, even if the tree is malformed. And the reason for that is, if you think about an IDE experience, right, like something like, let's take VS Code here, right? Code will rarely compile while I'm editing, right? So I'm still doing something here, so I have syntax errors all over the place. But you still want IntelliSense to work, right? If you hover over things, you want to get useful answers from the system, right? If I invoke, code completion here, you're still expected to know that, there's a body property, right? So the syntax tree, even if it's malformed, even if there's syntax errors, you have to be able to bind it in order to answer any meaningful questions that happen in an IDE context, right? So the problem isn't that the parser inserts tokens. That's just a fact of error recovery. But you want to be able to say, well, if things are inserted, then just don't do anything with them, right? So the real fix here is just handle the fact that certain tokens are inserted and don't do anything with that. By the way, Peter has apparently his birthday today, so congratulations. And let's see what we can do with that. So what are the cases where this can happen? So first, let's actually go here and say, let's actually do this and say, actually, let me do one thing. Bound literal expression 0. That was always my way to say I don't know what's going on, but I don't do that anymore. I removed all those usages, so I think it's complete in terms of cascading errors. Introduce type symbol error to represent unbindable expressions. This avoids cascading errors when part of an expression cannot be bound. Higher nodes such as binary expressions can detect this case and bail early. Okay, something like that. In order to address Peter's case, so let's just see where things can go wrong in the binder today. So where do we accept an identifier token today? Identifier. Here we go. So here's one example. Bind variable declaration. So let's say a variable declaration was incomplete and we have a null text here. So what would happen? Yeah, you get this, right? Now you get an argument null exception because we call try declare here. And try declare references the name is null, and then bad things happen, right? So one way we could fix this is by saying we don't declare. So we could either just completely bail here, but then the problem is you have to return some statement. So now I need to basically return a knob or something, which might actually not be bad. Do we have a knob statement? I think we do, right? Bound knob. We don't. Yeah, we could do that. Alternatively, we could just say there is a variable, but it has no name. We just don't declare it because there's also no way to look it up. Yeah, what's easier for us? It's probably easier for us to actually add the variable. Nah, I don't like that because then it's how about this? How about we just say let's try this and say declare right? So this should fix this problem. Right, so if we say show program and I say let unexpected node error expression. Oh, that's right. Yeah, so here's another thing we need to be careful with in our, every time we add a bound tree item, we also have to add it to the rewriter. Otherwise, this guy doesn't take that very well. So what is this thing here? So we would have to add this guy here and call this error expression, rewrite error expression, bound error expression, boom, 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 return node. Okay, so let's try this again. Bum, ba, bum. All right. Oh. Yes, so as we can see, when we actually have that input, we do have a block statement with a variable declaration where the variable name is unknown, and of course there's an error expression for its type. That is kind of what you would expect logically, right? So that seems a reasonable approach. It might be biting us later when we make assumptions like, so now the problem is our boundary basically has a variable symbol in the tree, but you can't find the variable symbol in the symbol table, right? In which we use scopes for. Maybe that's an invariant that we break later, where basically the assumption is everything we find in the tree can also be found in the symbol table. But we can deal with that later. Right now, that seems more like the right approach. So binding for statements, that's probably the same problem, right? So if we go and let's say for, yes, same problem here. We tried to declare a variable where none was specified. Given that the logic seems to be almost identical, I think I really want to extract this into its own method. So let's call an actual method and let's say declare variable. Yeah, not like this though. Let's do this. Introduce local. Let's call this identifier. Yes, and then let's do this guy. Yes. Okay. Let's call this bind variable. I guess. Oh yeah, that's also not helping. So we need this guy as well. To use local, yep. All right, so now we can do this extract method, and we call this bind variable. Bind variable, and then we can call this identifier, and we can call this type. And then we can inline this guy again into something that's a bit more reasonable. So where would that guy go? Let's move this all the way to the bottom. That's the general approach for helper methods. Okay, so now let's go all the way back up here, where we already have that logic with the question mark. So we said name is identifier, this one, declare is identifier is missing. And then we can say declare is more like this. That's right. Bool is read only. Something like that. And then here we would say is read only true. All right, instead of doing this, we now would say var variable. So lazy to typing. It's bind variable. Identifier would be syntax identifier. Is read only, and then initializer type. And then we can remove this guy, we can remove this guy, we can remove this guy. Okay, let's quickly check that we didn't break anything. Okay, show tree, no, show program. All right, that makes sense. For holy cow, that's quite a yeah, that's the rewritten and lowered version of the for statement already, so that's why that's a little bit unwieldy. But it didn't crash, and arguably it all has the right types. I had an expression statement, sorry, an assignment statement. Yep, that's all good. Of course, there's a ton of cascading errors now. We should probably fix this. Convert. If target type is not type symbol error and result type is not target as not type symbol error, and the types do not match, then we should report an error. So this is another case of a cascading error because of the target type that's passed in here from somebody else was an error, in which case we don't know what the target type is. If the result type is an error type, it also doesn't make sense for us to do anything. And this guy doesn't match, then we report an error. Otherwise it makes no sense. Okay, so let's try this one first. I don't know whether I invoked build. I should have invoked run. Let's see, this is show program. And then we say 4. Yes, no, we don't get a cascading error here. That is good. Get a bunch of parse errors. The parsing error is a little bit on the cascading side, but that's somewhat normal. I don't know. I haven't really thought about whether we can fix that easily or not. But parser errors are usually not that bad. All right, so then let's see what we have done here. So let's add this guy. Was our last commit? Yes, okay, so that means I should just add this guy there. And then we would say, oh yeah, that's right, we need to do, that's actually, the error expression needs to go in first. Yeah. All right, so now we can say we fixed this issue. Number 30. Fix error, fix exception when declaring inserted variables with inserted names. This fixes number 30. The only thing is, let me actually go over the binder, make sure we have all cases covered now. So where are other cases of declare variables? So we bind it here. Bind in 4. Okay, in the lookup we already handled this case. So we would say if syntax token is missing, yes, assignment. Okay, so here is an interesting one. I think parser-wise, we can never get into a state where the assignment expression was constructed with an inserted name expression. Or is that actually true? No, actually, that I think we can. So No, because yeah, you can only go down that path if no, actually, is that true? Expected token equals unexpected token equals to expected identifier token. Yeah, I don't think you can technically get into the state where this is inserted. Yeah, I think this is all the cases we have. Let's see what our pull request does. Probably want to edit the title to something more sensible. I think we have this episode label. That's right. We usually have actual titles, which in our case would be episode 10, string literals and type symbols. What? My build failed? Inconceivable. Yeah. Private protected is not available in C# 7. Please use language version 7.2 or greater. How am I compiling here? I am compiling for Netcore app 2.1. Why does it default to a higher version? I'm slightly confused by that. Yeah, I think we can do one or two things. We can either force to use a later version of C#, or, which might be easier for us right now, because the only language feature that we use that is not in 7.0 is private protected. But on the other hand, I don't like the idea that I'm stucking myself into this thing. So how about I just go here, I go to edit. There was a task to basically make sure to get the latest version of .NET Core Manager. Let me check that. I think it's this one here. It contains runtime, include preview versions. Where did I get about this task? Use this link. What? Well, what did it use? Let's make sure we at least use something newer than what we actually have referenced here. Where's that? Do I see what version it used? Version 2.1, no, that's... It doesn't really tell you what version it uses. I think 2.148 is the version of the command line task. That's the build engine. Yeah, I'm not feeling the vibe to debug CI right now, so how about we just do something really simple. We go back to our symbol thing here, where we introduce this thing. Instead of using private protection, we just say internal. I mean, it's internal at the end of the day anyway, so yes, it's slightly bigger visible in my assembly than it probably should be, but that seems fine. Replace private protected with internal. Rebase master. So where is our symbol? Where we introduce the symbol one? That would be here. All right, let's fix that. Let's push a new version of that. Yeah, I think the directory.build.props file wouldn't necessarily help me, because if the version of the SDK doesn't support the version of C#, I still have to change the CI system to use that, which I don't feel like doing right now. Let's just see how this build goes, and then I call it a day. No. Okay, screw it. I will have to probably... Okay, fine. I'll fix this one as well. Fine is... what did we say? Is read only. It's is where? I think it's in the binder, right? Binder 129. Okay, that's the only occurrence I think that we have. I think long running though, we really have to get to later version of C#, because I am now quite used to certain niceties, like for example being able to specify named arguments, even if they're not the last. All right. So where does add support for 4 statements? No. Bind variable. Yeah, I guess that's true. Anyway. Replace named argument with local. People that want a clean history. Yeah, I think that was the last commit. All right. Okay. All right. Hopefully that is the last. Yeah. My compiler on my box is. Oh, actually, it's a good point. Your message was on DevOps, right? Actually, you might be right, Lucas. You might be right. Yeah, maybe we should just add a. Still unclear to me why that wasn't the default, but I guess that's. Yeah, let's do that. Let's just bite the bullet now and do that. So let's say this is directory.build.props. And then just say lang version 7.3 lang version. Add directory, git add git commit -v add directory.build.props. We want to use the latest minor version. Actually, yeah, that's also, anyway, okay, works for us right now. We want to use a specific version of C# across all our projects. So this centralizes this setting. All right, let me rebase this guy. At the very beginning, so that we don't have any issues with that. So first of all, this thing should compile now, right? Okay, it does. Then let's go back here and fix this thing. What we actually wanted to do. So let's call this private protected, right? And then the second one was binder is read only. Okay, let's do this. Okay. And now let's do this. Add private protected. We'll rebase this guy anyway, so let's just see. Git commit use named argument. All right, this hopefully should now build. Let's give it another shot. Hopefully I named it the right way. Yeah, it is Lang version, I hope. Yes. All right, let's see. I probably could have said latest minor as well, but instead of saying 7.3, but good enough for now. I'm actually looking forward to moving to .NET Core 3.0 because we changed the way we represent the framework on disk and made package restores much cheaper. So that means less waiting in CI for things like that. Here we go. That worked out fine. All right, now it's time for me to rebase this thing in a sensible way again. Yeah, except I have to say what my baseline is. Jesus Christ. All right, so usenamed argument goes in here. Private protected goes after this guy. Okay. Now we have a sensible history. All right, I think we're at the point where we can call this success. So today what did we do? We basically added string literals and we added support for type symbols. Next week what I will do is I will add support for calling functions. And so that will be probably one of 2 episodes to add support for functions. First we will just start with built-in functions we can call. And then the week after, we will actually handle the ability to declare functions. I might break this up into procedures, meaning functions without return values and functions with return values, depending on how much work that ends up being. I hope you found this today useful. If so, please give the video a thumbs up and also consider subscribing so you get notifications next time I'm live again, which should be next week. I promise to do that. All right, thank you very much, and then hope you enjoy the rest of the day. Bye-bye.